Hello friends, welcome back again. We were continuing with the numerical, and in the last video I discussed with the theory related to the Taylor's equation. So now continuing with the numerical for the same. So this is the numerical we are discussing for the two-life equation, and for the same we had discussed the Taylor's two-life equation Vt raised to power n equal to constant. So now let's proceed further. We are having the numerical in which we are given a data for V and T. Once again. Yes. So we are considering the data for the two life and cutting speed. We are given a value of two life, corresponding value of the cutting speed, and another value of the two life and the corresponding value of the cutting speed. And it is asking us to evaluate the Taylor's constant and the two life exponent. So let's begin with the solution. First of all, writing the given data, we are having the cutting speed 150 equivalent two life 60 minutes. So these are the V1 and T1 respectively. And the second set, the second cutting speed 200 meter per minute, giving the two life 23 minute V2 and T2. So now friends, directly applying the Taylor's two life equation, Vt raised to power n equal to constant. So we had discussed that we can relate the different sets of Vt with the other sets of V and T. So one set is V1 T1, another set is V2 T2. So V1 T1 raised to power n will be equal to a constant, and that same constant will be equal to any other set. And in our data we are having that other set now apart from V1 T1, that is V2 and T2. So putting the values of V1 T1, V2 and T2, first of all we are equating V1 T1 and V2 T2. We are just forgetting the value of C right now. So putting on the values in order to evaluate the value of n, that is the Taylor's exponent. So we get the calculation as 60 by 23 raised to power n, that will be equal to 200 plus by 150, or 2.6083 raised to power n equal to 1.33. So now taking the log of both sides. So it will give us n log 2.60 equal to log of 1.33, and using a calculator we can evaluate log of both sides, and thus the value of n, Taylor's exponent, comes out to be 0.3. Now friends, it is also asking about the value of the Taylor's constant. This Taylor's constant is equal to the expression for any given set. In this we are having two given sets. One is V1 T1 and another one is V2 T2. So you can use any set, either evaluate V1 T1 raised to power n or evaluate V2 T2 raised to power n, and in both the cases the value will come out to be 512.31. That is, you can use either this or this, but in both the cases it will be same 512.31. that is the value of the C, which is equal to Taylor's constant. Thank you friends.